In this video, we will learn how to solve nonlinear systems of equations. A system of equations is generally two equations with two different variables in it. In order to solve an equation that has multiple variables in it, we need multiple different equations. So in courses like Algebra 1, you have done linear systems of equations, which an example of might be 2x minus y equals 3, and x plus y equals 4, and then you used the strategies of substitution or elimination in order to solve these for both x and y. Nonlinear systems are very similar. We're also going to use the strategies of substitution and elimination. The only difference is that now we're going to be doing this with nonlinear equations, things like circles and parabolas, and using the same strategies to solve them. So in nonlinear systems of equations, we have multiple different options for the number of solutions that we can have. Since we are not doing two linear equations or two lines, our equations can have more than one solution. In fact, they can either have no solutions, like in this first example here. The picture given is a line and a parabola. That line and the parabola will not intersect at all, so that means there's no solution. We could also have one solution, like the circle and the parabola, two solutions, three solutions, or four. Remember, the solution of a system of equations are any points of intersection. So when you're asked to find the solution of a system, it's not just going to be one number, like 4. That's not the solution. A solution is going to be an ordered pair, say 4, 1, because the solutions represent the points of intersection of the two functions. So it's always important, once we find one of the variables using either graphing, substitution, or elimination, that we go back in and we plug in our answer in order to get the other component of the ordered pair. So all of your solutions should be given as coordinate points. So in this example, find the solution to the system given the graph. We are already given the graph. Remember, find the solution just means find the points of intersection. So this one is kind of easy because we're already given the graph. We don't even have to do any work, actually. We just have to see where the two graphs intersect. So I have a circle that's in black, and then this shape in the blue is called an ellipse. It's like an oval. And you'll see that they intersect in two spots, both on the y-axis, so up there and down here. So the solutions to this system would be the ordered pair 0, 3, because that's the point where they intersect, and 0, -3, because that's my other point of intersection. We can also use the strategy when we're not given the graph, and we can use our graphing calculator in order to find the graph of the equation. So solve the system by graphing. The first thing I need to do is you need to put these two equations in a form that you can enter into a graphing calculator. Remember that your graphing calculator is always in the form y equals. So for both of these functions, the first thing we have to do before we can graph them is we have to get them set y equals something so that we can type it in. So if we take my first equation, 2y minus x equals 10, I'm going to solve it for y. So I'm first going to add x to both sides. So then I would have 2y equals x plus 10, and then divide everything by 2. So x plus 10 divided by 2 is my first equation. And then for my second equation, y minus 3 equals 1/8 x plus 4 squared. I'm going to solve it for y, so I'm going to add 3 to both sides. So then I have the equation y equals 1/8 x plus 4 squared plus 3. So now I'm going to take my graphing calculator, and I'm going to type in my two equations. So y equals, now the first one I have x plus 10, the whole thing divided by 2. And now for my second equation, I have 1/8 x plus 4 squared plus 3. And then I'm going to hit zoom 6. And you'll see that my two equations here, this is my first equation, 2y minus x equals 10. That's a line. And then my second equation is this parabola, which is my second equation, y minus 3 equals 1/8 x plus 4. So now I need to figure out where these 2 points intersect. So you have a couple different options here. If you go to second and then up here above trace, you'll see it says calc for calculate. So if I press second and then calculate, number 5 here is intersection. So if I click intersection, this will calculate the points of intersection for me. So it's asking is the cursor on the first curve, so that's this little dot here, and we'll just click enter for yes. And then it jumps to the second curve, we'll click enter for yes. It asks you if you want to guess, which I guess you could if you want, but if you don't, just click enter again. And then it gives me this point of intersection here, which is unfortunate. Let's try that again. I don't think that that's what should be the answer. So if we go to second, calculate intersection. No, the first one will be 0, 5. That's this point right here. And then if I wanted to find the second point of intersection, I could do it again. Second, calculate, intersect, and then you would just want to move the cursor down by the other point of intersection. So here, and then it jumps to the second curve. And then there's your second point. So my 2 points were 0, 5 and negative 4, 3. You could also do this by looking at the table. The table for the two equations. You want to see where their y values are the same. So here this would be 0, 5 for both. And then 3 and 3 for both at negative 4. So that tells you that those are your 2 points of intersection. So my solutions here would be 0, 5 and negative 4, 3. You can also solve systems just like you did with linear systems in Algebra 1 by substitution and elimination. So we'll do substitution here for this equation. Remember, substitution is when you plug one function into the other. So in order to do that, you have to get one of your equations equal to a single variable. I'm going to get this one, my second one, equal to either y or x. That way it will be easier to plug it in. So for my second equation, I'm just going to add the y to both sides, and I get x equals y plus 1. That means I'm going to take y plus 1 and I'm going to substitute it into my first equation anywhere I see an x. So now I would have y plus 1 squared plus y squared equals 13. And the reason for doing this is that so that I have one equation that only has one variable in it. Because after I have that, I can just use my skills for solving equations in order to isolate the variable. So remember, y plus 1 squared, you cannot just distribute the square to both terms. You have to FOIL that because y plus 1 squared is really y plus 1 times y plus 1. So I'm going to multiply that out. That would be y squared plus 2y plus 1 plus y squared equals 13. Now I'm going to combine my like terms. I have y squared and y squared, so that would be 2y squared plus 2y plus 1 equals 13. This is a quadratic equation. So that means I have to either factor it or use the quadratic formula. But the first thing that I need to do is I need to get it set equal to 0. So I'm going to subtract 13 from both sides. So I have 2y squared plus 2y minus 12 equals 0. I can divide this whole thing by 2 just to make it easier on myself. Y squared plus y minus 6 equals 0. And then I can factor this. This factors into y plus 3 and y minus 2. So that gives me the y values of negative 3 and positive 2. So those are my two solutions for the y's. But remember, a solution to a system is an ordered pair. So I need to get the x values that correspond to these y values. So I'm going to go back up into my original two equations, and I'm going to plug in those values for y in order to solve for x. So in this case, I'm going to plug in to this equation here, because that is much easier to solve than the first one. So I'm going to plug in my solutions of -3 and 2. So I would have x minus -3 equals 1. So this becomes x plus 3 equals 1, minus 3 from both sides, so x equals -2. And then my second solution was 2, so I'd have x minus 2 equals 1, add 2 to both sides, so I get x equals 3. So that means that the two solutions to this system of equations are 3, 2, and -3. Oh, sorry, I did this backwards. Oh, no, I didn't. I was right. Because x is 3, y is 2, and then for my second ordered pair, my x was -2 and my y was -3. So these are the two solutions to that system of equations. Which makes sense because the first equation is the equation of a circle, and the second equation is the equation of a line, so it makes sense that they intersect at two different points. My second method for solving a system is elimination. Elimination is when you basically add the two functions together so that something cancels out and that you're only left with one variable. In this case, I need to kind of adjust my equations a little bit so that they cancel out. Because I have an x squared and an x squared, I want to multiply one of my equations by -1 so that when I add them together, the x squared and the -x squared cancel. So let's multiply this second equation by -1. So then I'm left with my first equation, and then my second equation becomes -x squared plus 4y squared. Sorry, it should be a 9, equals -4. And then when I add them together, x squared and -x squared are just 0. Y squared plus 4y squared is 5y squared. And then 9 and -4 is 5. So now this is much easier to solve. I just divide both sides by 5. I get y squared equals 1. Take the square root of both sides. Remember, y then becomes plus or minus 1, which is important here because I'm going to plug in both +1 and -1 into my equation to see if I get two different answers. So now you can take either of the equations, the first or the second, and substitute positive and -1 into them to get the y coordinates. We'll just do the first one. It doesn't matter. You should get the same answer. So I'd have x squared plus 1 squared equals 9. So this is x squared plus 1 equals 9 minus 1. X squared is 8. Take the square root. So x is the square root of 8, which if you simplify that, that's 4 and 2. So that becomes 2 radical 2. So that means that the first point in my solution to my system was 2 radical 2 comma 1. And now let's do that for -1. So I'd have x squared plus -1 squared equals 9. Well, you'll see that this actually becomes the same thing because -1 squared is also 1. So I get the same y coordinate, or sorry, the same x coordinate for this y coordinate. So my 2 points in my system are 2 radical 2 comma 1 and 2 radical 2 comma -1. So when do you use each technique? Just some tips if you were just given a bunch of problems and it says solve, it doesn't tell you how, just some things to look for. I use substitution if the corresponding variables in the two equations do not have the same degree. So if you have one equation that is linear and another equation that is a second degree equation, that tells you to use substitution. Something like x plus y equals 4 and x squared minus y squared equals 1. There's nothing that you can do to the first or second equation that you're going to be able to cancel out a variable, so that tells you to use substitution. We use elimination if the corresponding variables in the equations do have the same degree. So if you had x squared minus 4y squared equals 0 and x squared plus 2y squared equals 1, I can use elimination here because both the x and the y values have the same degree. And then you can use graphing. Really, you can use graphing anytime. The first key is that you need a graphing calculator. And the second key is that you can easily solve both of the equations for y so that you can type it in. Just a tip when you are using graphing, especially if you have something that's in a second degree. So say I had the equation x squared plus y squared equals 9. I wanted to graph that on the graphing calculator, so I would solve it for y. So this becomes x squared, or y squared equals 9 minus x squared, and take the square root. Remember that when you graph this, you have to graph both plus and minus equations so that you get both parts of the graph. If you just graph the first one, the square root of 9 minus x squared, that's only going to give you half of the circle. So remember that when you take the square root of something, you need to account for both plus and minus solutions.